Hi everyone, my name is Scott Exton and I'm the Chief Programmer for IBM Security Verify Access. Today I just want to take a few moments to introduce to you the new IBM Security Verify Operator, which works in an OpenShift environment. So just by way of introduction, OpenShift is supplied by Red Hat and it's an enterprise Kubernetes platform. So it's something that bundles Kubernetes and allows you to run containers, but it builds on top of Kubernetes, providing additional management and APIs that will allow you to much more easily manage your cloud infrastructure. It's been designed to run inside of clouds, so you've got public clouds like Azure, IBM Cloud, and so forth, but you can also run it on-premise as well to create your own on-premise containerized environment. So that's what OpenShift is all about. The other piece of the puzzle is IBM Security Verify. Now, if you haven't heard of IBM Security Verify before, it is an identity as a service offering which is provided by IBM Security. And it provides a central authentication mechanism for all of your disparate apps, no matter where they run, whether they be running in the cloud, on-premise, or otherwise. Not only does it provide single sign-on, it also provides an easy way to configure multi-factor authentication, risk-based authentication, which allows you to have adaptive access decisions, provides user management, and other things as well. So it's a centralized authentication hub for all authentication and security hub for all of your different applications, no matter where they reside. If we start talking about licensing for IBM Security Verify, if you don't already have a license and you do have an OpenShift license, then you're actually allowed to have an unlimited user license for IBM Security Verify and the single sign-on capabilities of IBM Security Verify. So if you've already purchased OpenShift, there is a form that you can go to to in turn request a new tenant that will allow you to use IBM Security Verify. And the form URL is provided here on this screen. So now that I've explained what OpenShift is very quickly, of course, as well as IBM Security Verify, I just want to talk very quickly about the IBM Security Verify operator and what it does. So the operator is designed to allow you to consistently enforce policy-driven security in your OpenShift environment using the ingress networking capability of OpenShift and of Kubernetes. And this is done in conjunction with the Nginx ingress operator. So by using the IBM Security Verify operator, what this means is you can actually seamlessly protect all of your applications that are running within OpenShift, protecting them with authentication, authorization policies, multi-factor authentication, without having to change any of your application code. As a part of the operator as well, it will also dynamically register your application with IBM Security Verify so that you can more easily onboard the application and start protecting your applications. The other thing that I wanted to mention is the IBM Security Verify operator is a Red Hat certified operator, so it is already present within the Red Hat certified operator container. And what this means is it's already available in your existing OpenShift environment. And one of the follow-on videos will actually show how to actually install this into your environment. But we're not going to talk about that during this video. So when we start talking about the architecture, how does the Verify operator fit into your OpenShift environment? It actually works as an operator. So if you're not aware, operators are a Kubernetes concept that just provides a more easier mechanism for managing your applications. So people can write their own operators. It provides their own custom resources, which in turn allows them to essentially control applications. In our case, we have the Verify operator, which is something that we have written. We do rely on the Nginx ingress controller. So this is the thing that will actually process your ingress definitions and act as an entry point into your application. And it's front-ended in an OpenShift environment by the route controller. So the route controller is the thing that allows you to get access into your OpenShift environment. From there, we'll set up an ingress definition that will tell OpenShift to send requests for your application through the ingress controller. The ingress controller has been instrumented with code or configuration that will allow it to call out to our Verify operator to perform OIDC authentication in order to protect your application. And then once the authentication is successful, the ingress controller will then allow access through to your application. Now, one thing I do have to mention is in a standard OpenShift environment, you don't have the Nginx ingress controller. You would generally go directly from the OpenShift route controller through to your application. And that's by defining the OpenShift routes. In our case though, because we want to protect your application with authentication, the OpenShift route controller does not allow us to do this, which is why we have introduced this other certified operator, Red Hat certified operator, which is the Nginx ingress controller as an entry point into your application. Now I'll talk a little bit more about that on subsequent slides. So when we start talking about the authentication flow, don't get too concerned about the complexity of the diagram on the right. I'll go through that, but we use OpenID Connect as a single sign-on mechanism to IBM Security Verify. Now, for those of you who haven't heard of OpenID Connect before, it's just a simple identity layer that's built on top of OAuth 2. It is a standard, so lots of service providers support OIDC. And it's just a way of allowing clients to verify the identity of the end user based on the authentication which is performed by the authorization server. And in our case, the authorization server will be the Verify. So when we start talking about the IBM Security Verify operator, it's going to make use of OIDC Connect to exchange the authenticated user identity information with IBM Security Verify. Now, the operator will also include in the HTTP stream as HTTP headers the full identity token and authenticated username from IBM Security Verify, so that way your downstream applications know who it is that is accessing the application. So if we start talking about the authentication flow, first off, the user will make a resource request. That will be routed through to the ingress controller. Nginx has, or the ingress controller has already been instrumented to know that to access this application, authentication is required. So it will make an internal call, so it doesn't go back to the user. This is an internal call to the Verify operator, which in turn will return a 401 forbidden, which in turn will call our login API, which is the thing that kickstarts the authentication process. Now this interaction here seems a little bit complex or over the top, but it's just the way that the Nginx ingress operator has been written. But again, the end user won't see any of this. So the Verify operator will then generate the OIDC request and send a redirect back to the authorization endpoint of IBM Security Verify. At this point, IBM Security Verify is going to authenticate the user. So how it does that is up to how you configure Verify itself. It could be multi-factor authentication using a mobile device. It could be a cloud-based user registry. It could be an on-premise user registry. It's really up to you in how you configure Verify to control what happens during this authentication process. But once the user has successfully authenticated to Verify, a redirect is sent back to our Verify operator authentication endpoint. It will call out to Verify requesting the authentication token. The token comes back to Verify. It will validate the token to ensure that it hasn't been tampered with and it is a valid token. Then it will, at this point in here, the Verify operator has successfully authenticated the user, so it will send a 302 redirect back to the original resource request that was made by the user. Again, Nginx detects that authentication is required, so it will call out to the Verify operator. At this point, the Verify operator recognizes the fact that the user is already authenticated, so it just returns a 200 OK back to the Nginx ingress operator, which then tells the operator that this request is okay. It will also insert identity information as HTTP headers into the request and forward the request onto the application. The application will do its part and then generate and return the response. So it seems a fairly complicated flow, but the main thing to remember is from a user standpoint, they make a request, they get redirected to Verify for authentication, they get redirected back to the Verify operator for single sign-on, then they get redirected back to their resource and they get their resource response. So from a user's perspective, it's not too onerous. So the next question is, well, as an application developer, how do you actually protect the application? How do you actually register with Nginx, the Nginx ingress controller that authentication is required with Verify in order to be able to access this application? The way that you do that is by providing annotations to your ingress definition. So what's on the right-hand side here outside of that red box is your standard ingress definition, nothing special. But what we do is what the application developer does is adds annotations to that ingress definition that to provide the operator with the information that it needs to know in order to be able to register the application with Verify and also instrument Nginx ingress controller with information so that it can authenticate the user when accessing this application. So that's what the operator will do when it intercepts the ingress definition, and then it will register the application with IBM Security Verify and then instruments the Nginx gateway to require authentication when accessing the application. Now, one thing that's important to note here is that the service, so this defines the service. How do you get access to your application? The service definitions must be defined using a Kubernetes ingress definition so that it goes through the Nginx ingress gateway rather than your standard OpenShift route definition. So if you're historically familiar with OpenShift, in the past you might have used OpenShift routes to create your service definitions to instruct OpenShift how to get to an application. In order for the operator to work, you must instead use the Kubernetes ingress definition, which is just an alternative way of defining your services. When it comes to deploying the operator or in your environment, or not so much the operator, but deploying your applications in the environment, there's a couple of considerations that you really need to take into account. On the right-hand side in this picture, it kind of shows the network traversal for a request to your application. So when a client makes a request, it'll first traverse or first end up at your route controller in your OpenShift environment. From there, the route controller will send the request to the Nginx ingress controller. And then from there, the Nginx ingress controller will send the request through to the application. So we've got this chain of requests taking place. So the first consideration you need to take into account is where will the SSL termination take place? Will it take place purely here getting into the route controller? Will it take place here? Or will it take place here? Not only that, you also have to ask yourself the question, where do you require TLS protected traffic and where can you have unencrypted traffic? A lot of customers nowadays in a containerized environment, because they trust the environment, they ensure that there is TLS or encrypted traffic to get into the environment. But once they're in the environment, they allow unencrypted traffic to traverse inside of the environment. So that's one option. The other option, of course, is having SSL all the way through. When you define your route in the route controller, the route controller can be configured with pass-through mode or edge mode, so you need to make a decision what kind of mode you want it to run in. The Nginx ingress controller supports both HTTP and HTTPS. If you're using HTTPS, we need to do SSL termination here, so that way we can inspect the traffic. And then finally, of course, it's up to you whether you use HTTP or HTTPS going to the application. So that's some of the considerations you need to take into account. The other one that you need to worry about is how you define your ingress definitions and whether there is going to be a one-to-one mapping of application to host name. And by host name, what I'm really referring to is the name of the host, which is used in the URL to get through to the route controller. Now, Nginx itself has a limitation where you can only have a single unique host, or each ingress definition must contain a single unique host name. In other words, you can't have a host name across multiple ingress definitions, the same host name, because if you do, the Nginx ingress controller will just pick one of those and not and ignore the other ones. So you really do need to make sure that each ingress definition contains a unique host name. On top of this, the Verify operator only supports a single Verify application. So this is an application which has been registered with Verify. It only supports a single one of those for each ingress definition. Now, as a result of this, of course, it's going to be much easier in your environment if you have a one-to-one mapping of application to host name. In other words, each application has a single ingress definition, and that ingress definition contains a unique host name which is going to be used to access the application via the OpenShift route controller. Now, it is possible to flip that or to reverse that, so you have multiple applications for a single host. But when you do that, you still need to ensure that you have a single ingress definition for all of your applications, and that you have a single Verify application for your ingress definition for your host. That's probably not going to be a problem in most situations or most environments. It's only if you want to have customized policies that it does kind of impose some limitations or restrictions from a Verify perspective. So this has been a fairly quick video. If you want to find out more information on the Verify operator, go to the GitHub project documentation. You can see the URL here. I'll also be producing a couple of additional recordings which actually demonstrate the usage of the operator and show the operator in action. So I hope that you found this useful, and hopefully you'll enjoy using the Verify operator.